Hello, everyone, and thank you for joining DataCon LA. Welcome to the data engineering track, and soon we'll be listening to Delta for Your Data, How to Efficiently Track and Store Deeply Nested Data Changes session with Sep Dehpour. I am Eli, your host, and our co-host today is Stephen. We will be moderating the chat and Q&A for you during the session. Today, we have as our guest Sep Dehpour, and he will be talking about Delta for Your Data, how to efficiently track and store deeply nested data changes. Sep Dehpour is a staff engineer at FAIR, where he has led various teams, including the original internal tools and the search team. Sep is the creator of DeepDiff, a data diffing library, which has over 1.7 million downloads a month. DeepDiff is used by companies such as Google, Netflix, Uber, etc. Without further ado, I'll hand this over to the speaker, and thank you for being here, Sep.
Hello, thank you very much, Eli. And that was a great introduction. I'm going to share my screen. Let's see. All right. I think, can you see my screen?
Yes.
There's no problem. Yes, probably, right? Okay.
Yes, yes.
All right, cool, awesome. Well, thank you very much for coming to this talk. We're going to talk about Delta for your data. Let's start with seeing what is already out there. There are a lot of, this is not a problem that is really unsolved. There are other solutions already that touch some parts of the problem. The first one that comes to mind is Git itself. You're gonna have, let's say, a JSON file, and you just commit, and as you change the file, you can do branches and merges and all sorts of things you're familiar with. The problem with Git is that it does line by line. So if, let's say, 2 lines changes in your file, it considers it that the data has changed, but technically your data has not changed. It's the same thing. So it's good for small sizes of data, but not really designed for actually checking data changes. Next one is diff and patch, which come with Linux automatically. A lot of you probably are familiar with it. You just do a diff between 2 files, and it creates a patch file, and then you can apply that patch file to the file you originated this from. It has the same problems as Git because the conflict resolution is at the line level. But it's a very useful tool, and in fact, the interface of it is what the Delta tool from DeepDiff is designed from. We're going to see soon. Next one is Quilt. I hope I'm pronouncing it right. The tagline is manage data like code. So Quilt is an interesting tool. It seems like they're moving more towards data discovery and not necessarily versioning your data. What they're doing is you have immutable data on S3 buckets on AWS, and the versioning is done by AWS itself. So in that sense, if you have a lot of changes to, let's say, large files, each time a new version of the whole file is stored. So you're going to have a lot of extra data stored where instead of just the small changes to each file. Next one is QRI. This is an interesting tool, similar to Quilt, is built on top of IPFS, which stands for Interplanetary File System. Very cool name. It seems to me it's kind of like Torrent. Interplanetary File System has some differences. You can look it up online yourself. But at the end of the day, it has the same problems as Quilt for data versioning and data storing data changes, because it stores the whole file every time. Next one is David, I think is pronounced, and it's specifically designed for image-oriented data services. It is actually a data service, but it is designed for distributed version image-oriented stuff. Next is Dolt. This one is very interesting. Basically, you have the Git command line tool, but your data is stored in a MySQL database. So from a user perspective, you can do anything that basically Git command line allows you to do, but the data is in MySQL database, which limits it to the size of the MySQL database that you can get. But indeed, it's very interesting. You can still do branching and a lot of other things. And the last one I'm going to talk about briefly is Databricks Data Lake. I don't have experience myself with it. I've just seen demos of it. But if you're familiar with Parquet, this one is actually a storage layer that brings ACID transactions to Apache Spark and big data workloads. It's not just a tool, it's a whole storage layer. That's a service. So the reason I put this one here is because it has the same name as the DeepDiff's data, which is a tool I've made, and they both share the same name because technically under the hood, they're supposed to do the same thing in a lot of cases, which is getting the delta of different data that you have. I'm gonna go just do a quick self-promotion of what is DeepDiff. So DeepDiff has 1.7 million downloads a month. If you check out my website, zepworks.com, you will see there. And I've put links to different open source packages by various companies that use DeepDiff. So you can see Netflix, and Google, etc. You can click on it and see how it's used. And it has a bunch of features, and we're gonna briefly cover almost all of them today, from difference, delta, deep search to deep distance. And all right, so now that we're here, so if you want to do some coding that I'm going to be doing, generally you can install DeepDiff by doing pip install DeepDiff. But specifically for this talk, I'm going to talk about certain features of DeepDiff that are not released yet. They're in the dev branch. So you have to check out the dev branch, and you can visit this address, github.com/Severman DeepDiff 3dev to see the dev branch. And we're going to continue. We're going to start with some interesting data. If you search in Google for nested data example, one of the first things that comes is from Kaggle. There's this nested and repeated data. It's basically some Google Analytics data that Google has put out there, and you can download from Kaggle. And we're going to run some query that, again, I found on Kaggle. The whole point of this query is month by month, we want to see the bounce rates per source of data for this specific Google store. Okay, so if you look at briefly at this query, what it's doing is saying between 2017 0601 and 2017 0631, do a bunch of things grouped by source. Source means like where the user came from, and we want just the top 10. By the way, all these slides are already uploaded to DataCon LA, so if you have difficulty finding these links, you can grab it from the slides. So this is an example of the output of that file in the notebook, the Jupyter notebook. So you can see for 2017-04, we have Google as a top source with a bounce rate of 49%. Then we go 05, Google is still at the top, but you see the bounce rate is slightly changing, 06, and we go to 07. Some items are changing. Our goal is to use DeepDiff to get some sense of this data and see at the end of the day, for example, which months were the most similar to each other. So let's start with and what we are interested in is the bounce rate and rank changes. Let's start with the command line tool. We type DeepDiff and just the name of the files. I've downloaded the files from the Jupyter network in the form of CSV, so it's easier to just see the results. If we run this command, we get a ton of results that basically don't make sense a lot because everything basically has changed between the two CSV files. If we zoom in, you see it says And remember, CSV, when it loads to Python, is basically, each row is basically, it basically comes in a list. So it says row 1, bounce rate, it had the old value, had new value, and for each one of them, what has changed. This is not very useful, but it's a start. Let's look at this data again, and if we think a little, you'll see if we group by things based on source, maybe get a lot more useful data. So we just pass group by source to the exact same command we had before. We get a slightly better data. So now we see, for example, direct, like people who clicked and directly came to this website, the bounce rate has changed this much, and these total visits has changed, etc. For partners, this is the bounce rate, etc. Now, what we are interested in is the bounce rate and rank changes. We're not interested in these other like total visits, etc. It's like it's pollution on the screen basically. There's this thing called exclude regex path and exclude path. If you go to basically the documentation for DeepDiff, and I click on DeepDiff, there's the exclude path. I don't want to go into details what's the difference of them, but in this example, you can just use exclude path to say, hey, we're not interested in total visits and we're not interested in the total number of bounces. So when we do that, the data is a little more meaningful now, like because we didn't care about those numbers. What we see now is how across the line, like the ranks, for example, here, Google has changed from 6 to 7, bounce rate, how much it has changed. And what's interesting here, we see that, for example, from months 4 to 7, Facebook has been added to top 10 sources of visitors to this website, and Reddit was dropped, for example. Now, if you look at these numbers, you see a lot of numbers are very similar, and maybe we're not that interested in the difference between, in decimal points, right? So what we have in DeepDiv, something called significant digits. And let me go to the documentation. So I think it's here, significant digits. Yeah, it's the first item. Basically, what we do is we try to round number based on a few different formulas. So you can, if two numbers have not changed that much, we ignore the difference between them. And you can read more here. At the end of the day, we try to convert the number and round it into some form of string and compare the two strings. Let's go back to the slides, you'll see more. Here, for example, from those differences between those two files, we see these two numbers are basically the same, right? We don't really care about this much change, but we probably should care about 52 becoming 58%. This is a bounce rate. What we do is, and I'm going to jump into the details soon, so don't worry about the details, but what we pass, these are two new things. We're saying significant digits 0. This is the significant digits after the decimal point. And we say number format notation E. If you're familiar with the E, basically is the scientific format notation. I'll get to that a little more soon. But once we pass these, you see the results of the difference between the two files is now a little even more meaningful. So that 43 point something is removed. Now we see 52 versus 58 and 49 versus 43. This is like a this is the gist of change between these 2 months, months 4 and month 7. Okay, so let me now go behind the scene. What does that significant digits means with some examples? If you install DeepDiff, basically under the hood, it's using this function from DeepDiff called number to string. And here you see we pass a number, this floating point number. You say significant digits 1, it turns it into a string 43.3. Now the same number we pass for significant digits after the decimal point being 0, we get 43. So far, so good. We pass the second number here, 43.71. With significant digits of 1, we get 43.7. But when we pass 0, significant digits of 0, we get 44. This sometimes confuses some people, but at at the end of the day, if you think about it, 43.7 was closer to 44 than it was closer to 43. Okay. So going back here between these two numbers, there's this, again, when we're here, normally we are passing another variable called number format notation. And by default, that's F, standing for fixed point. But you have two options, fixed point and scientific notation. And you can see the difference now. So this is now the fixed point version. We pass number format notation being E, we get the scientific notation. I think people who have scientific background, they're familiar with this notation. But what you can understand from this is if you pass a significant digits of 0, basically you are losing, like we had 43, we're losing the rest of this, right? We don't care about, we just care about 40, doesn't matter what's after that. Okay, and let's get back to our example that we had. And I think now it makes a little more sense why we got what we got, which is 43 somethings disappeared from the results, but we still have the bounce rate changing from 52 to 58. This one is basically rounding to 50. This one is rounding to 60. Okay. All right, so now we get to the more interesting question, which is between these monsters of data, which ones are the most similar? So if you are familiar with Levenshtein distance, probably some of you are familiar with it. Levenshtein distance, and I think I had it loaded here. So basically the goal of Levenshtein distance is to give you the minimum number of character edits or additions or removing basic operations to turn one array of strings or characters into another array. It gives you the minimum. But in DeepDiff, we have this concept of deep distance. The difference between this and Levenshtein distance is that first of all, it's for nested data, and it can accept any sort of Python object. And second is not the minimum number of operations. It is not the minimum. It is just the number of operations to convert one object to the other based on the parameters you pass to DeepDiff. And I think it's going to get more clear as we go. But this, the goal of it is any two arbitrary object, you should be able to get a numeric value between 0 and 1 that says how similar these two objects are. 0 being they're exactly the same, 1 being very different. So if we go back to our slides, let's go here. All we do is we pass this parameter called get deep distance. And when we pass that, you see between months 4 and 7, the deep distance is 0.168. Between months 5 and 7, the difference is less. You see it's 0.118. And 6 and 7 is even less. So you see, it's kind of like what we should have expected. Months 6 and 7 are the most similar. And months 4 and 7 are the most different. So in this example, probably you could have written some other formula to come up with what is the most similar, but just imagine you can have any arbitrary Python object, you could have NumPy, whatever it is, compared to some other object and get some numerical value of how similar or different they are. Okay, so let's go with the example 2. Excuse me. So in this example, I'm going to go through this one quickly because it has some similarities to the first one. Is basically we have two CSPs and Jimmy Brown moved from downtown LA, this zip code, to Santa Monica. And what we do is we get the difference using DeepDiff command line tool. Okay, that's what we expected. And let's look at this T2 CSP again, just to remember what it was. T3, the only difference is these two lines have changed, have replaced each other. the data is the same, right? So if you were using Git, this would give you a difference between these two, or if you were using the Linux diff command. But with DeepDiff, there's this thing called ignore order that you can pass. When you do that again, it only tells you what is different between these two CSVs, regardless of the order of items. It even detects the repeats and ignores them. So in this case, T4 CSV, we have Jimmy Brown twice with the same information. You pass this to DeepDiff, you get exact same results as before. And what's more interesting now, we're going to get to this thing called delta in command line tool. It's called patch because I try to make it similar to the Linux patch command. So you just say DeepDiff with all these parameters, create patch, and you put it in a whatever file name you want. Let's call it patch one. And let's create a new file. Now we call it T1 new. Probably I should have named this something else. But the only difference between this and T1 is we have two new rows. And let's remember patch one, the only thing had changed was Jimmy had moved from downtown LA to Santa Monica. So now we create, we apply the patch. It's very similar to the patch command in Linux. You apply patch one we just made. Remember patch one, all it says is Jimmy moved, right? We apply to this new CSV file. And once we apply, Jimmy is updated. You see? All right, so let's look at our files. We have the original T1 new, which was Jimmy was still in downtown LA, and we have another file, T4 CSV, with a bunch of other data. What we want to do is now create two patches. Here we have create two patches between T1 and T1 new and T1 and T4. One of them is just, remember, they had some new rows. The other one is basically Jimmy moved from downtown LA to Santa Monica. And these are basically these two patches plus T1 CSV, as you would expect. This was T1 CSV. We apply the first patch. Jimmy moves to Santa Monica. We apply the second patch as the new rows. So far, so good. Let's move and see the potential that this patch or delta has for you. The patches can be applied to any object. Let's grab a YAML file. Okay. This YAML file has a bunch of other information that's not in the CSV. You see, like the phone, zip code, etc. And you can do exactly the same thing. That patch that you made from two CSV files, you can apply to a YAML file, and now you see between these two, Jimmy has moved to Santa Monica. Just look at it. Once you apply the patch, the formatting changes because it doesn't care about preserving formatting, but it creates a new valid YAML file and updates you see the zip code of Jimmy is updated. You can even apply it to other files, like it supports YAML. You can apply it to pickle, the CSV, JSON, all sorts of files. Okay, you can apply it to a random Python object. Let's just do this same thing. Remember, in Python, patch is called delta for DeepDiff, and we created just a custom class. You see, all it has is two attributes, A and B. We pass these functions so we can print them nicely. We create two objects, instantiate them, and we get the difference between these two objects, create the delta of these two objects. Remember T1, we pass 10 and 10, T2, 10, 12. If we add the T1 to delta, we get T2. So literally you can apply this to any object. Could be NumPy, whatever.
Sorry to interrupt. 5 minutes before Q&A.
Okay, thank you very much. All right, so let's look at some other features that DeepDiff has. You're looking for something in the file, you can use DeepGrip. It's kind of like the grab command that Linux has. but it gives you more power in terms of like you can grep in a pickle file or YAML file and exactly find the path to the thing that you're looking for. So in this example, remember the YAML file had Sarah as one of the items. We say, okay, number 2 in the in the array in the YAM, the first name is Sarah, for example. And then you can use this tool called deep extract and extract exact that path that we grab here, root 2, and see what was it inside the YAML file. Again, you can do this on a pickle file or a JSON file, doesn't matter. It could be super nested. Nested data, it was the subject that I want to talk more because most people who use DeepDiff, they're dealing with like deeply nested data, but it usually doesn't fit the screen. But this is an example actually between these two files. You see, like visually, it's very difficult to know what has changed. And let's actually make a smaller example that's maybe more tangible. You see between these two files, if you just look at them, you see some values seem like they have moved, and probably what's this, key 5 has changed. It was value 5, now it is changed, right? If you run DeepDiff between these two, we get a bunch of, without any settings, we get a bunch of values that are not necessarily as interesting. We pass ignore order, slightly gets more interesting, but there's still too much going on. If you do DeepDiff -- help, you get a bunch of parameters, a ton of parameters. You can check on the zepworks.com for the documentation. But basically, once we pass ignore order with a cache size of 5,000, there's a lot of think about, if you're familiar with dynamic programming or memorization, it needs some cache size when it's doing ignore order for deeply nested objects. Here we set the max cache size to be 5,000 items and a cutoff intersection for pairs. I'm not going to explain what this means because there's a ton of in the documents you can find all sorts of details. But basically, once you pass all these, you get exactly the path. Look at how deeply nested this is. Exactly the path of any item has changed. All right, so conclusion, you see DeepDiff comes with a bunch of tools, both in command line and in Python modules. From DeepDiff, Delta command line tool is called DeepPatch, grep command line tool is called DeepGrip, and extract. You can use these tools for extracting insights from your data. And I hope you find this talk useful. Please let me know if you have any questions. I'm here for another, I think, 10 minutes for answering questions. Thank you very much.
So thank you, Sep. If you have any questions, please write them in the Whova chat, in the Whova Q&A, and we will bring them up to Sep right away.
I think I have like 10 minutes left, right? I rushed through some parts of the talk, so I was not sure how much time I have left.
So I have a question, or well, I find it interesting what you did, because I'm working with deeply nested Mongo data, well, JSON data that is incredibly hard to process in a lot of ways, and I think your library could do a lot of good for us. So I might actually use it in our work. I'd never seen it before, and it seems very useful. And I was just wondering how a lot of the companies that are using DeepDiff do use it in is it mostly in like analysis, or is it mostly in um, like business logic in some other way or something?
That's a great question. First of all, you just reminded me something like that DeepDiff, I have been working on it for a number of years. I think it's close to 8 years maybe now or more. But there's a ton of people who have contributed to it. Let me go here. So if any one of you see like here, I think we have like maybe 40, 50 people here. If you're at all interested in joining the project and doing some PRs or even bug fixes or something, please, by any means, you're more than welcome to join. And now going back to your question, it seems to me there are two different types of users for DeepDiff generally. So in Netflix, for example, the data science team contacted me at some questions. So they were using it for analysis, but but let's say in Google DeepMind, which is here, it's going to show up. The way they're using it, they have the states like it comes maybe more similar to your use case. That you have a state of a system in a maybe deeply nested JSON file or something, and you want to see how much the states have changed, right? So you have a state, you're like, this is my desired state or what I expect the state to be, and this is my current state, what exactly is different? And you can pass all these parameters to basically thresholds that you're like, hey, I don't care if the number changes like 10%, for example, right? Or I don't care certain parameters change, like say exclude passes, or I don't care if it used to be a float, now it is, I don't know, a decimal. So I think that is, and the other use case. The third use case I've seen, which is similar to the second use case, is let's say you have this is actually one of the people who used to be a core contributor to DeepDiff was using it this way. So in his website or whatever system that they were building, they had the user's state, not the system state, but user's state. Like a user has looked at these things, I don't know, has clicked on this, etc., etc. And over time, you want to have an idea of how the user's interactions have changed. Like if you have like snapshots of different behaviors each day, you want to see what is different between them. And what he added to DeepDiff is, I'm going to show it here. There's this thing called tree view here that he used a lot. Basically, the whole point of tree view is when you compare two objects and it says, hey, this and this are different, you can go up through and traverse up the tree of nodes that made up those two objects that were compared to each other. So you can easily go up and say, okay, so I don't know, these parents were these objects and the parents of parents were these objects, and finally this was the mutual parent between the two objects. That's something that I personally have not used, but seems like a lot of people use it. I hope I answered your question.
Yes, yes, you did.
So we have
yeah, I was just going to announce it. We have a question. Dr. Vincent Sea said, hi, I just joined a few minutes ago, sifting through the PowerPoint. Pardon if this has been covered, but does this track text data well?
All right, that's a great question. So we do have, Python has a library called difflib, which is basically what you see for, like let's say when you do, is a same or similar algorithm to what you see when you do like git diff. Basically line by line, there's conflict resolution. And DeepDiff uses exactly the same thing for multi-line text. I think I have some examples here. Let's see. In the text view. some examples. Let's see. If not, I'll just type something. I'll just type something here. Let's go to DeepDiff. Right. So let's say you have whatever, hello. What the hello word, right? And T2 equals hello. Right. You say DeepDiff. Did I import it? Maybe not. From DeepDiff import DeepDiff. So this is a multi-line change, right? DeepDiff T1, T2. Let's see. Yeah. So you see, like, it literally uses the same library. I think you're probably familiar with this format. Is that what changes in what line? If you printing it, probably line by line looks better. Let me see. So if I go diff, I don't know. Anyways, maybe here. Okay, I forgot. It's a while since I used this, but basically it does work on the multi-text input. The only thing that I've not added yet is the delta object, which is you can apply, or patch, the same thing that you can apply to other objects. Doesn't support this yet. Personally, I've not had a need, but if you have a need, I can always add it. It shouldn't be difficult. And I think we have a few minutes left.
He had a follow-up. So cool. And only for English for now?
So if you're talking about, and correct me if I'm wrong, maybe I didn't understand your question. DeepDiff itself doesn't care about language. It just cares about data. And the difflib library that's behind the scene that it's using for multi-line text, that I'm pretty sure should support like basically Unicode, so any language. If your question is if all these parameters, so if I go back, let me get out here. If diff, sorry, DeepDiff help, like if they type it wrong, install dash install it yet here. Okay, so if I type this, if your question is, are these parameters, because there's a ton of them, are they translated to other languages? No, not yet, at least.
So I'm going to have to end us there. Let me say thank you, Sep, for your presentation. And I appreciate all the attendees for questions and interactions during this session. Please contact the speaker if you have further questions regarding this topic. The Q&A will be not monitored, but the chat is still open. Please provide your comment and feedback to us or the organizers on the community board, or start a discussion there to connect with others in the DataCon LA community. Thank you for joining today's presentation, and I hope you have gained some insights from this session. Have a wonderful day, and thank you for being a part of this year's DataCon LA. Thank you again, Sep.
Bye. Thank you.